Hello and welcome to episode 9 of this SharpC2 development series. In the last episode we built the core agent module and we were able to send commands from the team server to the agent. In this episode I want to expand more on agent modules, specifically where the core agent module is built into the agent. We also want to have external agent modules that can be loaded at runtime, and I will also show how I've extended the team server to accept output back from the agent temporarily. We can have a look at that code real quick. So I've added two new server commands here, one for agent output and one for agent error. And then at the moment for each one we're just writing to the console. So we're just going to expect a string back at the moment, and then we're just going to just print it to the console so we can see it. The only real difference is that agent output has a little plus and agent error has a little minus. So this is just a temporary way for us to see output from the agent. So the core agent module is just a class that implements the iAgent module interface, and the external agent modules are going to be exactly the same. They're just going to be in their own standalone projects. So if we create one, as a new project to this agent modules folder, and I'm going to choose a .NET Standard project, a class library project, and we'll make a new folder to keep them separate, agent modules. Now I've been thinking about all of the different functionality that we might want within these agent modules. The core ones up here are the ones that we're going to have built into the agent. We've already implemented sleep and exit. We're going to do load module today, and I've also thought maybe we should have clear to clear that queue command. So if you issue a command to an agent that you change your mind, you don't want to execute that, before the agent checks in you can clear the queue, and then a check-in command for the agent to resend it to load modules. So I was thinking that if we remove an agent from the user interface, it would remove it from that list of the list of agent session data that we have on the server side. And then even if we get a check-in, the only information that we get back from the agent is its metadata, but the loaded modules is not included in that metadata. So this is like a maybe. Maybe the kind of the remove from the user interface only actually removes it from the interface and not from the back-end server. So I'll put it there so I don't forget about it, and we'll see where the development takes us. I've also got a bunch of file system commands, so these are very basic navigation, copying files, removing files and directories, downloading and uploading, some networking commands, some system commands, so getting environment variables, setting them, killing processes, getting our user ID, running commands, running PowerShell, keylogging, screenshots, different types of token manipulation, mimikatz, powerpick, and some lateral movement. So this is a quick brain dump of all of the functionality that we want. Now, I kind of alluded in the last episode, part of the reason why we want to split these out into modules is that so the initial delivery of the agent in terms of file size is not gigantic. But also we don't necessarily want to deliver like things like Mimikatz that I would consider that really high risk, as in if you're going to deliver Mimikatz onto an endpoint, you should reasonably expect perhaps that that's going to get detected and your agent is going to get killed. So for those kind of OPSEC reasons, I want to be able to give the operator a choice as to whether they're going to, send this stuff down to the agent. So that it just gives a bit of extra flexibility. But I kind of want to be able to have a balance of, okay, well, we don't want 50,000 DLLs that we have to push, but we don't want too many. Sorry, we don't want too few, so that maybe if Mimikatz was in like this DLL with all these other commands, as soon as we want to do PowerShell, for example, we're pushing a PowerShell capability and a Mimikatz capability. And if Mimikatz is causing causing the agent to die or be detected, then that will take PowerShell off the table as well. So we want to be striking a sensible balance between, having too few or too many DLLs. So what we'll do is we'll create a file system DLL to do some of these. The only one that we'll implement in the episode is actually just print working directory. I don't think I'm going to show development of all of these things because they're quite boring. Maybe some of the interesting ones when we get to like networking. Maybe we could do like reverse port forward could be in here one day, and socks could be in here as well. But I think I'll save videos for just the interesting ones. Like PowerShell import I think would be quite interesting. Make token stuff will be quite interesting. Mimikatz will be interesting. PowerPick will be interesting. Some of these might be, but some of the other ones are quite benign, and I don't think they'd make for very interesting videos. So we'll call this project, we'll just call it file system. And then the reason why I want them as a .NET standard is because we can compile the project to DLLs that target lots of different frameworks at the same time. So if we open the project file, by default it's .NET Standard 2.0, but we can change this to like Net 4.0 for the .NET Framework 4. And if we wanted to, we could put .NET Framework 3.5, but I think I've already made my feelings on that clear. We could also try and add, I don't know what the shortcode is. I don't know if it's 5.0. But if we look at the team server, I've already upgraded this from .NET Core to .NET 5. So the roadmap for .NET is for .NET Framework and .NET Core just to become .NET. So at some point .NET 5 and .NET 6 will almost replace .NET Core and .NET Framework. So from a roadmap perspective of the project, I want things to be targeting .NET. Thinking about cross-compiling agents and modules, I don't want to develop .NET Core. I would rather just develop for .NET 5 and .NET 6 and just wait for the popularity of those frameworks to kind of catch up with where this project is going to be. I'll take that out for now. I think maybe I have to just keep that like that for just one, perhaps. And if you build view output, okay, rebuild. We've built this debug and then .NET 4.0 directory. So let's add a reference, and we're going to add references for the agents, and we're going to call this agent module, and it's going to implement iAgent module. We're also going to change the namespace of all of these just to agent. And then when we implement this okay, so maybe I shouldn't add both of these. Okay, yeah. My mistake. Okay. So because this class is called agent module as well, and this model is called agent module, we have to define these specifically. And so we can just follow the same pattern as we do for the core agent module. So we stick on an agent controller and the configuration controller. Budge init to the top and say agents equals agent controller and config equals config controller. Return new agent module. Name, call this file system. Description, just call it file system commands for now. So we'll have a new developer. Okay, and the commands. And like I said, the only one that we're going to implement is print working directory. So that's the name of the command. The description is just prints the current working directory. The help text is just print working directory. Now in the agent command model, I initialize the visible as true by default, so we don't have to explicitly set it for every command. We only have to set it to false if we want it to be false, so by default it will be true. The callback can be print working directory. And the pattern that we're going to do for these is going to be something like, we're going to do a try catch. If we catch, we're going to call this send error method on the agent controller, and we're just going to give it the message. Otherwise, we can do something like var results equals directory dot get current directory, and that's a string, so we can just send that by agent send output method, and we just give it the result. So if we have a quick peek of these, we're saying that the module is core and the command is agent output, which is what was in the core server module, and then the data we're just going to stick in, we're just going to encode the string to a byte array. And then the same for error, we create this new C2 data, and we call send data on both of these, which is a private method here, where it just takes in that C2 data and calls the send data method on the com module, which queues it up to be sent on the next check-in. So these are just little shortcut methods to try and make the development of a module a little bit easier. There'll definitely be cases where we have to send more complicated output rather than just strings. So this looks okay to me. We'll rename this class to agent module. Okay, and all we have to do is build it. And now we have the DLL. So to load the DLL within the agent, what we'll do is we'll expect it on the API as just a base64 encoded string. So we'll say var assembly is assembly dot there we go, assembly dot load. This data will be a byte array of the base64 encoded string, right? So we have to do convert from base64 string, and the input of that will be encoding dot get string of data. Okay? And then we'll do another try catch. If for whatever reason we're going to throw an error, we'll just send it. And then we'll do module is the assembly. We're going to create an instance of agent, because that's the namespace, dot agent module. So that's the class. And then ignore case is true. And then we're going to say if the module implements the iAgent module interface. So this is a way to check that we're not just pushing down any random assembly. So if this is not the case, then we'll send an error and the error will be assembly is not of, or let's say assembly does not implement iAgent module, and return. Otherwise, the agent module is the module as iAgent module. And then we can register it. So we call register agent module, and if you recall the register agent module, we'll add it to the list of agent modules on the agent controller. It will call the initialize method on the module, and then we're going to tell the team server that it has indeed been registered. So, quite simple really. So let's put a breakpoint here. And let's start the team server. Start listener. Now I want to show as well that this will work with the payload generated from the Roslyn compiler. So I'm actually going to, I've already made a bunch of changes, well not really a bunch of changes, in the compiler. What I've done is I've added, not there, it's in the payload controller. All I've really done is just added all the additional references that are required, given all the development that we've put into it over the last few episodes. So let's go to payload. We're going to give it that listener ID, and we're going to say .NET 4. Output type is exe. And we have assembly. So I've got nothing on the desktop. So we'll do, how do you make font bigger in PowerShell? System.io.file, write all bytes. C user desktop agent.exe. System.convert from base64 string. Okay, so now we have the agent. So we'll run it in command prompt, and we should just see no tasks, no tasks, no tasks. Same as the last episode. Okay, good. And in agents, we have the agent with all the stuff as expected. So the command we're going to send to it is Although I've just completely realised that we can't. I was putting a breakpoint on here, wasn't I? That was the whole point. How ridiculous. I obviously didn't think that one through. At least it shows the compiler's working. HTTP agents. Now what I find really cool, right, is if we go into this file system DLL and we'll put a breakpoint here and run the agents, you can see there's a little error here and it says the breakpoint won't be hit. No executable code of the debugger's target code type is associated with this line. So quite rightly, the debugger has no idea how we're ever going to reach this code in the DLL. So now that the agent's same agent's checking in again, I still haven't fixed this issue with the core module loading twice, but at least it lets us know that the agent is checking in again. Right, core load module, and then to load it we can do system.convert to base64 string system.io.file read all bytes dev SharpC2 agent modules file system bin debug net40 file system.dll and pipe it to the clipboard. If you didn't know about clip, it's like my number one tip. It's amazing. So hopefully when we run that, let's make sure that we've got the breakpoint in the agent core. Yep, so we should hit this breakpoint. The next time this checks in. Cool. So the assembly has loaded. And we now have the module. It is implementing the interface, so we skip over this. And then we can register it. So the info is, yep, all of this file system info. We add it, we initialize it, and then we send the data to the team server. So we can just continue at this point. Now, when we hit continue, notice that this is the DLL in the debugger, and the error on the breakpoint is now gone away. I just find that super cool that the debugger knows that it can now hit this code. The session data should now list the new file system module, which it does. So now we should be able to specify file system as the module and print working directory as the command. So we should hit this breakpoint. There we go. the result is correct, and we're just going to send it. So we can just continue from that, and hopefully up here somewhere this is the team server, remember? The next time it checks in, okay, so we're not getting that output. Let's just try again. Don't care about that. Okay, so we got it that time. So maybe something is wrong somewhere. I'll have to dig into that a little bit more. But you can see that we actually got some output. Now, let's try and force an error, just for the sake of it, really. What can we do to force an error? Not really sure. We could push an assembly down. Not sure that I've got just a random assembly. Oh, I do. Let's have a look in what's in here. Oh yeah, we can push Rubius. Why not? Tools, Rubius, bin, debug, Rubius. So this should call assembly.load correctly, but then at some point it will either fail this maybe and hit this catch, or we might hit this error. But either way, we're gonna get an error, I think, which is really what we want. Oh, that's a big string. I don't even know if we can push data that big. Okay, still didn't throw an error. Try again. Nope. Looks correct. So we are sending it. Team server's not printing it. So there's clearly some bugs somewhere. Never mind. Can we break? On the team server side, on the core server module. We should be able to break here when we get an error. So we have. No, we haven't. Oh well. Well, there's clearly some bugs somewhere. If we're not hitting this, then maybe the agent isn't sending the data properly, or it's not finding the callback. I think I'll stop messing around with it in this video. All I really wanted to show was how the external agent modules are going to work, and we've had some limited success there. So, like I said, I'm going to continue doing a bunch of this development off camera, and next episodes will probably be on some of the more interesting functions. We also need to think about how we're going to do different types of payload spawning. Like, none of that is in here at the moment, so we'll need to implement Donut at some point on the server side so we can generate shellcode. So stay tuned. If you've got any comments, questions or queries, hit me up on Twitter or leave some comments below. Thanks a lot, and I'll see you in the next one.